In this example, we're going to learn how to rationalize denominators. And basically, the whole entire notion of rationalizing denominators just basically means rewriting your fraction without a radical in the denominator. So it's basically what that means right there. So this just basically means no radicals in the denominator. Okay, it's supposed to be a little square root thing. So there's no radicals in the denominator. So once you rewrite your fraction, so it no longer has a radical in the denominator, then you're done. You know that you've rationalized the denominator. Okay, and it's a really simple process. Check out this tamale. So look at part A here. 5 over radical 11. The way that you rationalize a denominator is you multiply the radical, just the radical, by itself, top and bottom. So I want to multiply this top and bottom by radical 11. So radical 11 and times radical 11. Now, make sure that you notice this is that if I multiply top and bottom by the same number, I have not changed the problem because it's like multiplying by 1, right? 1 over 1 is 1, or 10 over 10 is 1. 12 over 12 is 1. Radical 11 over radical 11 is just 1. So really, I'm just multiplying by 1. Okay, so just a little insight to mathematics is, if you're wondering like why are we doing this? Well, really, it's not a matter of, we're not changing the problem, just the way it looks, but it's still the same problem. It's still 5 over radical 11, but we're just gonna rewrite it so it's not gonna have a square root, or third root, or fourth root, whatever, just no radicals in the denominator. Okay, watch what happens here. So 5 times radical 11 is just simply 5 radical 11. And radical 11 times radical 11, the answer is just 11. The little trick is that if it's the same thing twice, then it's always going to be that, because this right here is square root of 121. And square root of 121 is just simply 11. So now look, we just rewrote 5 over radical 11, which is equivalent to 5 radical 11 over 11. These two numbers are the exact same thing. If you're like, no way, dude, man, they're not even the same. I mean, look at the way that they look, and there's more 11s and all that kind of stuff. Okay, well then, get your calculator out and put 5 over radical 11, and then put 5 radical 11 over 11, and you will nicely see that they are the exact same decimal. Okay? And I know that has to be true mathematically because I just multiplied our fraction by 1. Radical 11 over radical 11. Okay? All right, let's go on to part B over here. Again, what I want to do is I want to get rid of the radical in the denominator. So I'm going to multiply top and bottom by radical 5. Okay? So 5 radical 6 times radical 5 is 5 radical 30. Again, I multiplied the radicals together right there. And that's going to be all over 5, right? Because radical 5 times radical 5 is radical 25. But that's just simply 5. Oh, dang! Wata! And that just gives us radical 30. 5 on top, 5 on the bottom. Those just cancel and give us 1. So it's 1 radical 30, but we don't need to put the 1 because it's a ghost. All right, last example for example 2 is negative 8 over radical 18. Now this one's going to require just a tad bit more work because you see how we can break down radical 18? So you should always do that first. If a radical can be simplified, let's do that first, and then we'll rationalize. So I can rewrite the bottom as radical 9 times radical 2, right? 9 times 2 is 18, and 9 is our perfect square number, which now becomes negative 8 over 3 radical 2. Okay, square root of 9 is 3. Now remember, when we rationalize, we only multiply by the radical. So if I want to rationalize this, I'm only going to multiply by radical 2. Okay, not 3 radical 2. I'm only going to multiply by radical 2. Okay? Now let's see what we get here. So negative 8 times radical 2 is negative 8 radical 2. And down here, we have 3 radical 2 times radical 2. Remember how we learned that if they're the same thing, then we just get just 2. So that'll be 3 times 2, right? So what I want to do here is before I multiply 3 and 2 together, do you notice that the 2 can actually divide into the 8? Okay, so I'm going to divide the 2 into the 8. So 2 goes into 8 4 times. Okay, do you see that there? So then negative 4 radical 2, negative 4 radical 2, all over 3. Okay, now you could have multiplied 3 and 2 and get 6. So that means then you would have had negative 8 over 6. But then you have to divide this top and bottom by 2. And then that's how you would have got negative 4. And then you would have got 3 on the bottom. So you would have got the same thing if you multiplied out. But I just noticed that, oh, we'll just go and divide the 2 into the 8. Goes into it 4 times. And that is it.